Bismillahirrahmanirrahim. This video is about amplifiers, and this is from a book by Mr. Sedra. Okay, now let's understand the basic concept of an amplifier. If you see this diagram, this is an amplifier. It is being fed by a signal from microphone. Now the microphone is a transducer. Transducer means a device which converts signal from one form to another. So microphone is converting voice signal into electrical signal. Now the electrical signal from the transducer is generally very weak, and it cannot be put directly to the speaker, and it has to be or it needs to be amplified, and that is why we pass it through an amplifier circuit. So the amplifier increases the power of the signal, and then it goes into the speaker or the actuator. If you look at this diagram, amplifier generally has two terminals input and two terminals output, and its symbol is like this, or most commonly a symbol of this type is used. Now if you look at, if we call this as the output, then output VOT is related to, if this is input, VI by a factor A. Now A is the amplifier gain. So let's say this signal VIT is 2 micro, and the amplifier is amplifying 10 times, therefore the output will be 20 micro. So that is the basic concept. And this type of amplification is called the voltage gain. So in the voltage gain represented by signal A, V, it is output divided by input. And a term linear is used because the characteristics of this is like a straight line, linear line. So we'll see from this diagram, this is the transfer characteristics, is a straight line. So therefore this circuit we call, or this amplification we call linear amplification. And this is a more detailed diagram. You can see this is the input now. Current I1 is entering, current I2 is leaving, and this is load, and the voltage across load is VOT. And so again the gain of this amplifier is V out divided by V in. Now let's try to understand the difference between an amplifier and a transformer. I'm sure you know what is a transformer do. Transformer converts the voltage, like if one of the transformer, it is changing 110 volt input into 220 volt to 220 volt output. So what is it doing? It is amplifying the voltage or increasing the voltage. Let's not call it amplify. It's increasing the voltage by twice. But there is one very important point, that is the power on this side is same as the power on the other side. So if it has increased from 110 to 220, that means whatever was the current here, that current will reduce by half. So current is going down, and only then the power will remain same. Take an example, 110, and let's say current is 2, then what will be 220 power, 220 watt on this side, or 220 VA, let's call it. Then what will happen to current? Current here was 2, it will become 1. So 1 multiplied by 220, again 220 VA. So the power remains same on both the sides. But in case of an amplifier, we can increase or can get increased power, we can also get increased current, and we can also get increased power, or increased voltage, increased current, and increased power. And this all happens because the amplifier is connected to an external battery. Here there is no battery. Here the battery is now providing power to the circuit, and so we get everything amplified. So that is the main difference. So this is the source of additional power. There is another voltage source. So this is also the source of additional power. And so in this case, the power gain will be called the load power, P load, divided by input power. So whatever is the load connected here, the power of the load, we expect it to be more. So that power divided by the input power will be called power gain. Same way, current gain will be the output current divided by input current, and the voltage gain we have learned already that voltage gain is V out over V in, and so we can write that the power gain is the voltage gain multiplied by the current gain. This we have to remember. Now we can write all these, the gains etc., in terms of a dB, which is called decibel. It's a measurement tool, or the number for measuring power etc. And the basic definition is that whatever was the power, if we take log of that power and multiply it by 10, then we get the value in decibel, dB. Now that is for power, the gains in decibel. Same technique for voltage and current, but here we are now multiplying by 20. And why we are multiplying it by 20? If you recall that P is V square over R. So if we take log of this, then it will be 2 multiplied by 10 log. So that is why it will become 20. And same here, it is I square into R. It should be, it's wrong here, I into I square into R. However, there is a power of 2 here, so if we take log, it will be 20. The power supplies of the amplifier, you can see here, we have a positive power supply connected and we have a negative terminal of the power supply connected. The DC power delivered to the amplifier is PDC, VCC, IC. Now this, remember, the battery is supplying the power. So this positive battery is supplying the positive battery power voltage we calling VCC, VCC into the current of the battery ICC. So one power is coming from here, other power is coming from here. V double E is the voltage multiplied by IE. So PDC is actually the sum of the two powers. This is the power by the positive side battery, this is power of the negative battery. Couple of more terms. You can see that the power supplied by battery and power supplied by signal source, if this is also supplying some power, then the sum of these two will be the power dissipated in the load and power dissipated in the circuit. So we call it PL, or power delivered to the load, plus P dissipated in the circuit. So this is important. Then there is another term called efficiency, and I'm sure you know efficiency is output over input. So in case of this circuit, it is the output power, PL, load power, divided by the power supplied by the battery, that is PDC. This is called the efficiency of the circuit. Now let's do example 1.2. We have to understand the question first. Consider an amplifier operating from plus minus 10 volt power supply. So this is the amplifier circuit. We have a plus 10 power supply and we have a minus 10 power supply. It is fed with a sinusoidal voltage having 1 volt peak. So the signal fed from here has 1 volt peak. So this is V input. and delivers a sinusoidal voltage output of 9 volt peak to a 1 kilo ohm load. So this is a 1 kilo ohm load, and the voltage here is V out is 9 volt peak. Amplifier draws a current of 9.5 milliampere from each of the two power supplies. So the power supplies, this current from the power supply is 9.5 milliampere. Similarly, this current is 9.5 milliampere. The input current of the amplifier is found to be sinusoidal with a 0.1 milliampere peak. So this current, input current, is 0.1 milliampere peak. Keep in mind, the voltages are all in peak, not peak to peak. Okay, what we have to do, we have to find the voltage gain, we have to find the current gain, we have to find the power gain, we have to find power drawn from the DC supplies, power dissipated in the amplifier, and the amplifier efficiency. So the first point is the voltage gain. We know voltage gain is V out over V in. Out was 9 volt peak and in is 1 volt peak, so 9 over 1 will be 9 volt by volt. And now to convert this into dB, we take 20 log of AV, so 20 log of 9, and this is equal to 19.1 dB. Similarly, the current gain is the output current over input current. We know input current to be 0.1 milliampere peak, but we don't know output current, but we can find from here. We know this voltage to be 9 volt. We know this current, this resistance to be 1 kilo. So we can find the output current to be 9 volt divided by 1 kilo is equal to 9 milliampere peak. So putting in these two values, 9 divided by 0.1, peak and peak gets cancelled. So it is 90 ampere by ampere. And here also we take the log to get into the dB. So 20 log 90 is 39.1 dB. Now let's see, just a reminder, it is fed with a sinusoidal voltage of 1 volt peak, so this is input 1 volt and delivers a sinusoidal voltage of 9 volt, and that is the output voltage was 9 volt. So what we need to find is the power. Now the power is P load divided by P input. So P load is V out into I out in RMS. Now V out here was 9 volt peak and I out we calculated or found to be 9 milliampere peak. Now one point you have to keep in mind, when you're converting peak into RMS, then you divide it by 1 over under root 2. But if you are converting peak to peak, then you have to divide it by 2 under root 2. So this you have to keep in mind. Actually, we are just taking half of this and then using this formula. Anyway, now here the voltages or currents are in peak. So we write the peak magnitude divided by under root 2. Similarly, the current magnitude divided by under root 2. This was in milli, and therefore our answer will be 40.5 milliwatt. You could write milli here and then you can get the answer, but engineers are sometimes and they get lazy and assume that you understand. Anyway, so this is the output power. The input power, we know that the input voltage was 1 volt peak, and so it is 1 over under root 2. And input current was 0.1 milliampere peak, so this is also divided by under root 2, and so the answer is 0.5 milliwatt. Because of this milliampere, this is milliwatt. So we have got the two powers. Now we can find the power gain. So just dividing the two, 40 milli divided by 0.5 milli. So the answer is 810 watt by watt. And if you take log, now keep in mind, we have discussed earlier that for the power we use 10 and for the voltage and current we use 20. So don't make this mistake. Keep it 10. So 10 log 810. So the answer will be 29.1 dB. And now the fourth item was power drawn from the DC supply, that is the power drawn from the battery. So here it is easy because we know that both are in DC, the voltage is in DC and the current is in DC, so no peak, etc. So simple multiplication. So this is from the upper battery and this is from the lower battery, and so the answer is PDC is 190 milliwatt. Then the power dissipated in the amplifier. Now we have to use this formula. We have discussed this, that the PDC plus the power by the signal source should be equal to the power across the load and power dissipated. So from here we get power dissipated to be PDC plus PI minus PL, and we know all these. We have calculated all this. So PDC, we plug in the value of PDC here, 190. PI, we had calculated it to be 0.05, and P load, we had also calculated it to be 40.5. So this is 40.5 the load, and this is the input. So plugging in, we get the answer. Power dissipated is 149.6 milliwatt. Okay, now we come to the final point, amplifier efficiency. So the efficiency is the output power divided by the battery power, DC power. So this is output power PL, we had already calculated from here, 40.5, and PDC we calculated from here, 190 milliwatt, and so solving this we get the efficiency to be 21.3%. Okay, now finally we do the two exercise questions. Again, these are very easy questions. First one, an amplifier has a voltage gain of 100 and a current gain of 1000. Express the voltage and current gains in decibel and find the power gain. So it's simple. Voltage gain AV is 100 V by V. So we just to convert into dB, we take 20 log of the gain. So 20 log of 100 will be 40 dB. So I hope you know how to use your calculator to calculate this. Okay. Then the second point was the current gain. Again, same way, current gain was 1000. So we just take 20 log of 1000. So this will become 60 dB. Now to calculate the power gain, we cannot multiply the dBs, but we can multiply in the ratio form that we have. So AP is AV into AI. AV, that is the voltage gain was 100 and current gain was 1000. So this become 100,000. And now we can take log that AP dB is, again you have to keep in mind that you have to use 10, not 20. So 10 log of 100,000, and this will give you 50 dB. So this is 1.10. Now let's do the last question on this video, that is exercise 1.11. The question says an amplifier operating from a single 15 volt supply. So this is one supply 15 volt, the other is grounded. Provides a 12 volt peak to peak sine wave signal to a 1 kilo ohm load. So this is load across this, the voltage output is like this, it is 12 volt peak to peak. So keep in mind it is peak to peak, not peak. Okay. And draws a negligible input current from the source. So from the source we are getting almost zero current. The DC current drawn from the 15 volt supply is 8 milliampere. So this current is 8 milliampere. We have to find the power dissipated in the amplifier and we have to find the efficiency of the amplifier. So we have learned the power equation, that is the power supplied by the battery plus power supplied by the source is equal to power consumed or delivered to the load plus power dissipated in the circuit. So from here we can write P dissipated is equal to PDC plus PI minus PL. So let's find out PDC. PDC is the power supplied by the battery, so the voltage into current. VDC, IDC. VDC is 15 volt DC and IDC is 8 milliampere, so it will be 120 milliwatt. PI is 0 because of the negligible input current. And now P load, we know this formula is V out multiplied by I out RMS. We can also write in terms of V over R, so V square or V square V RMS square divided by RL. And now we have to convert this into what is given, V peak to peak. So this formula we'll use. Now this was for V peak we used earlier. For peak to peak we'll divide it by 2 under root 2. So V peak to peak divided by 2 under root 2 whole square divided by the load resistance. Now peak to peak is 12 divided by 2 under root 2 divided by whole square and 1K. So we get an answer of 18 milliwatts. So this is the power supplied to the load or consumed. So power dissipated, now we plug in the values that we have found, 120 plus 0 and minus 18. So we get the power dissipated as 102 milliwatt. Now efficiency, the formula is that power consumed by the load divided by DC power. So the load power was 18 milliwatt and the DC power is 120 milliwatt. So we get the answer to be 15%. So I hope this gives you an understanding as to how to solve this type of simple problems. Thank you.